Okay, just repeating what I said before, hit the wrong button. Your toolkit, and it's not toolkit, it's tool, yes, come on, y'all understand. Okay, toolkit, quadratic function. Okay, f of x equals x squared. You do vertex stretch by factor 8, that's done first, because you got to do multiplication before you do additions and subtractions. And then a horizontal shift and vertical shift in either order. You get a f of x minus h plus k. And if you don't understand that, go back and review chapter 1 because you really need that picture. Okay, so we learned, and you learned it in your course. So make sure you know that that is the form. The vertically stretched function f of x by factor a, shifted h units in the horizontal direction, k units in the vertical direction. This is what you have. You substitute x minus h for x, and you get x minus h quantity squared. Okay, so that's a times quantity x minus h squared plus k. Now I asked everybody to square this, and I didn't see anybody on the first pass that was actually doing that. People wrote this down, so this tells me your algebra needs an upgrade. So you really need to be conscious of that. Okay, this is just, there's a standard formula for this. You've had algebra 2, even algebra 1, you would know this. Okay, if you retain anything that you knew, you would know there's a formula for this, and at least you would know that x minus h quantity squared means x minus h times x minus h. When you square something, you multiply it by itself. So can you multiply x minus h by x minus h? Give you another minute to do that. Okay, so it's x minus h times x minus h. Now, squaring doesn't distribute over addition or subtraction. There's no distributive law here. You can't say that this is x squared minus h squared, for example, which is what I see a whole lot of. Okay, didn't see too much of it here, but that's something that I'm never surprised to see. No, it's x minus h times x minus h, and you use the distributive law. Okay, and x minus h times x minus h is what? If you could write this in either two ways, we're going to write it as x minus h times x minus x minus h times h. Okay, distributive law. That makes sense. Okay, whatever you multiply by x minus h, you multiply by x, then you multiply by h, and of course you change the sign because of the negative. Okay, that's then x times x minus h times h. Okay, x minus h times x is x times x minus h times x. You're just doing the distributive law on the other side. Okay, we did it from the left here, and now we're doing it on the right because that's the way the expressions came out. But it's the same idea. Now it's minus, and I'm going to put minus in parentheses around what I get from x minus h times h. And of course, x minus h times h is x times h minus h times h. That equals x squared minus hx. And then you distribute the minus sign through here, you get minus xh plus h squared, because minus and minus will give a plus. Then hx is the same thing as xh. This gives you x squared minus 2hx plus h squared. Your mom's a little uncomfortable with this camera because Zoom puts a big old banner across the bottom of the page. I just want to make sure we've got the bottom of the page. Okay. Well, so far, so good. So let's see now. So, understanding that that's what x minus h quantity squared is, we find then that a f of x minus h plus k equals a times quantity x squared minus 2xh plus h squared plus k, which is just then a x squared minus 2axh plus, and I'm going to put these last two terms in parentheses, a times h squared plus k. Now, you don't need to know that. What we need to know is if you have numbers for a, x, and h, you can do this, okay? Now, I'm going to go say that this equals then ax squared plus bx plus c. And that should be a familiar form to standard form of, or the general form of the quadratic expression. Okay. And for b is your 2ah, and c equals ah squared plus k. This is important. This just comes along. So what I want you to do before we do anything else is, once you do all these steps, we'll just plug in, use what I just wrote as a formula, do all the steps for what's the formula? 3f of x minus 5 minus 6, where f of x is your toolkit square. Okay, well, steps are identical to the steps we used here, but of course we've got to understand the rules. F of x minus 5 equals f of x equals x squared. We've replaced x by x minus 5. So f of x minus 5 is x minus 5 quantity squared. That's just plain function notation. Okay. The x minus 5 squared is x squared minus 10x plus 25. So 3f of x minus 5 minus 6 equals 3 times the quantity x squared minus 10x plus 25 minus 6. And that comes out 3x squared minus 30x plus 75 minus 6. We can do 75 minus 6, and that's going to be 3x squared minus 30x plus 69. Okay, so your algebra needs to be up to work to do that very quickly. You have to understand the distributive law in order to do this. So think about that, but what we then found is 3. Now you've got these steps to go through, get this expression, but there it is, it's not 75, it's 69. And now, we start with y equals x squared. We stretch it out by a factor of 3. Okay? Well, that multiplies all the y coordinates by 3. So for example, we've got this point, the y coordinate is this. What's 3 times the y coordinate? It's this, and this, and this. So here's 3 times the y coordinate. Here's your x coordinate for this point. Okay, so this point is going to be moved all the way up here. It's been moved 3 times as far from the x-axis. I am recording that, yep. Okay. And same with all these other points. This point is going to move way up here somewhere. This point is going to move way up here somewhere. And you're going to end up with a function that's vertically stretched. So this is y equals 3x squared. Now, first chapter, over this, okay? Did problems. Drew vertically stretched, horizontally shifted, and vertically shifted graphs. Okay, so you need to bring it together and understand what's going on for the squaring function. Okay, so that's all we're doing with the quadratic function. Okay, they all come from the squaring function. Well, then we have to shift over 5 units and down 6. Okay, so I'm just going to say we shift every point over 5 and down 6. I'm just going to say, let's just think where the vertex goes. Vertex goes over 5 units and down 6. So this shape moves over here so that okay, so here it is. You just kind of focus on the vertex. It moves over this far and down this far. And then you just draw the same shape. You just take this shape and slap it down here. Okay. Now, I didn't do a very good job of the shape. I could have gone rectangles and stuff like we do in my class, but not every class does that. Okay. So there it is. All right. Well, then this point, what would the coordinates of this point be? Write them down. So it's R. X coordinate Y. Okay, now, right, finally, everybody wrote that one down right. And again, from what I've seen, the understanding of the coordinate plane that people bring into pre-calculus course is very, very shaky. Okay. So I wasn't absolutely sure everybody would get this, but y'all are hard and everything, and you got that. Okay. Pretty straightforward. If you take 0, 0, move over 5, you're going to be at 5. Move down 6, you're going to be at -6. Everybody understands that. Okay, so this then is the graph of f of x is the x squared function. This graph here is the y equals x squared function. You know, I should have done a little color coding here. So we're sure to see the first graph is finished. I'm going to kind of make this vertical stretch graph like so. That's what I had written 3x squared. And then down here, I could have done this different color, but we understand now. This graph has been moved out of these positions now. To graph 3f of x minus 5 minus 6. Which is 3 times quantity x minus 5 squared minus 6, which we found to be 3x squared minus 30x plus 69. Okay. Now, what if you just have 3x squared minus 30x plus 69? Okay. What if you just knew this? How would you figure this out? If you didn't already know that it was f of x minus 5 minus 6. If you didn't know what the horizontal and vertical shifts are in the vertical stretch. Well, vertical stretch is 3. Where do you see 3? Here. 3 is multiplied by x squared. Okay. You inherited this 3 from the 3 here. Because when you squared the x minus 5, you multiplied through by 3 to get a 3x squared, right? After squaring, you multiply by 3. So this 3 has persistence. From here, here, here it is, and here it is. Oh, here it is. So this is your vertical stretch. Make sense? Now, how in the world are you going to find your horizontal shift and your vertical shift? They're not at all obvious. Vertical stretch is going to be right there in front of x squared. It has to. Okay? Well, A is 3. This is your vertical stretch. B equals negative 30. At this point, your question is, so what? Okay. And C equals 69. I just put the so what on that. And while the so what is, axis of symmetry. It's x equals negative b over 2a. Now, what's the axis of symmetry? for this graph? What vertical line is this graph symmetric with? Write it down if you know. It's going to give you a minute, either you know or you don't. And I just want to check and see if anybody does. First of all, I suspect that people haven't locked in the idea of vertical and horizontal lines. Okay, I opened math introduced it some time ago, so you know it's easy to miss stuff. Okay, I'm reading some pretty advanced stuff, and I'm not writing stuff down. I'm just reading it, which is not a good way to learn. But I want to see just how hard it is to learn really challenging stuff without writing it down. I'm finding that it's pretty much impossible. Okay. My point is, I read, I reread, I reread. I probably reread the part on well, a certain part of general relativity a dozen times. And every time I reread it, I see something I missed. Okay, and I understand it a little better to the point where I could almost tell you about it if you have a lot more math in your background. Okay, almost looking at Christoffel symbols. Okay, and I understand what they do and stuff, but I haven't written anything down, so I really just can't do it. I start writing it down. Okay, a lesson for how to learn, because you should understand very well by now, especially if you're in microcalculus class, that this axis of symmetry here there's your axis of symmetry. What is the equation of this line? X equals 5. Okay. And since, of course, when I wrote down here, I said x equals negative b over 2a. Okay. Now we know from the graph and from the shifts that this is x equals 5. X is 5 everywhere on this line, and that's what it means to be the line x equals 5. Okay. That's the only thing the line could be, because the only characteristic it has is that every point has x coordinate 5. Okay. That should be clear. So think through that again, because you're going to, especially if you're in my class, you're going to have to write down equations, lots of vertical and horizontal lines. And you've already done it a bunch of times. Okay, you have to know what they mean. Okay, now, that's very important for what we're doing here. Okay, so tell me, you know what the values of A, B, and C are. What does this come out? A equals 3, B equals 30. What do you get? Write it out, work it out. But yeah, now did you see the connection there? It's not. Okay. Good. Most of you got it. And everybody had, you know, B over 2A. But make sure you write it out. X equals negative B over 2A. Don't expect to remember from here that X equals negative B over 2A. Don't make yourself look back here to see where those numbers came from. Write it out right here so you can connect it. This is the negative of negative 30 over 2 times A, which is 3. Okay, well, the negative makes it positive. So this is 30 over 6. And now we say, aha. uh, okay, x equals 5, which happens to agree as it had better with what we did over here. So I saw something like 5. Okay. Makes sense? Well, that's a key to being able to graph a quadratic function. So if I give you another quadratic function in general form, which is the ax squared plus bx plus c form, tell me what the vertical stretch and axis of symmetry would be for this function. Give you a minute to process it. Okay, now some people have gone off into quadratic formula land. Okay. Which is actually really a good thing, except you're not answering the question that we're posing here, right? So the question we're posing, well, it's very simple. Vertical stretch is 2. The axis of symmetry is that x equals, is the line x equals negative b over 2a. A is 3 and b is 12. A is in front of x squared, b is the number in front of x, and the number you got left over there in the end is c. There are other things we can call that right now. Let's look over at the end, okay? So you get x equals -2. You agree? I think some people got something different. So either you did something wrong or, oh, wait a minute, no, not 3. I was thinking, well, somebody must have gotten their x from over there. No, I did. Okay, it's 2 times 2, which is -12 over 4. I said that a was 3. Somebody should have yelled at me right then. Whoa, what are you doing? Not looking at what I had. Remember what I had before. Okay, so this is -3. Okay, can you sketch a graph and just show me that axis of symmetry? Nothing else. Do that kind of quickly, because we want to move into quadratic formula land here in a minute. Okay, all that's required to do what I asked you to do is to sketch set of coordinate axes. You draw a vertical line somewhere to the left of the y-axis and call that x equals -3. And of course, that tells you what x is for any other number on the x-axis, because scale has to be consistent. So right now, there's 3 units. 1/3 of that would be 1 unit. If I put a line over here, you see that that's further to the right of the axis than this is to the left. So that might be x equals 5. So it would be x equals 2. It's going to be x is going to be further from the y-axis than 3. If I'm over here, we don't need to do that. Now, some people try to draw the graph. Okay, and I certainly appreciate your efforts, but you can't draw the graph until you know the coordinates of the vertex. Okay, so there's no point to trying to draw a graph, but you know wherever it is, it's going to be symmetric about this. It might be up here, might be down here, okay, might be upside down. It isn't. If this is negative, it would be upside down. It was negative. Okay. So do we understand? There's an axis of symmetry. We just found it. We know the vertical stretch, which would allow us to make a pretty decent plot. So the next thing we want to do is figure out where the vertex is. Okay. Well, the vertex has the x coordinate -3 because the vertex is on the line x equals -3, right? So it's -3 something. How do you find the something? You plug -3 in for x and see what you get. Does that make sense? I'm going to write that as function notation is y coordinate is h of -3. And h wasn't necessarily a good name for this function, so I'm going to change its name right now. We've used f and g, and I used h, because it comes right after f and g. I don't want to use k, that's the next module. So I'm going to use s. I can use any letter I want. And we haven't used the letter up to this point. It's the first time we've used it, right? So I'm safe to go back and change it. Won't change anything. So s of -3. What's s of -3? Look it up. Okay, now have the class and have a problem with this. Okay, s of -3. You go back to the definition of s of x. X has been replaced by -3, so you replace all the x's by -3 and just work on the arithmetic. Okay, so I'll write out what you need for x squared is 12x minus 4. And this is what you want to write out. Write it out like I'm writing it out so that it stays with you, not just long enough to do the assignment. And you did these things back in chapter 1. Write it out completely so that when you need it, like you do now, it'll be there. Okay? Don't just be content to get the right answers and move on. You gotta get it into your head. Okay? So make sure you do. So that's half the class knew what to do here. So that's a -3. X has been replaced by -3. So you replace all the x's by -3. Okay, well, that's 18 and that's -40 and 18 minus 40. negative 22. Okay. And I know that you can work that out. And it would be good if you write this out, to write out every term so you're sure you have it right. But so when I said evaluate the function and at -3, that gives you the y coordinate. Well, provided -3 is your vertex, right? So it's easy to find the vertex here. And it's easy to plug that into the function to find the y coordinate, right? Because vertex is the next coordinate. Think about the next value, you plug it in the y. So you get -22. So now we know, okay, I haven't scaled everything to the y-axis. I can -22 here. Be in place to label it, right? So here's our vertex. It's a -3, -22. All right. Now, how are we going to graph function? Well, we can say this. If x equals 0, what's y? Plug 0 into the y-intercept. Y-intercept is s of 0. Now, let's write all this out, but with 0 here. And that's going to be 0, that's going to be 0. You're going to get -4. It's generally very easy to find a y-intercept. So we have the point 0, -4. Where's the point 0, -4? Well, if that's -22. -4 is probably about maybe here. It's got to be less than 1/5 of this, because 4 is 1/5 of 22. Okay. So this is a y-intercept. Now I can sketch a parabola that's through that y-intercept and wobbles around over here. And I choked. I got close to the edge of the board and I made a asymmetric parabola. But even with this, can you estimate what the x coordinates are, the zeros of the function? This point, the zeros are the x coordinates. What do you think the x coordinate of this point is? What do you think the x coordinate of this point, at least it should be, if I'd have drawn this as wide as I did this part? Okay. Okay, well, we got estimates. Some people wanted to estimate x equals 0. Now, from where you're sitting, it probably looks that way, but graph goes through the y-axis of y plus -4. And after that, it's to the right of the y-axis. It's not all that far to the right. Okay. So we have estimates. Zeros and x-intercepts. Somebody estimated -7, 0, and 1. Now, 1 would be about this big, so it's probably less than 1, but you don't want to get into decimals, and it's just a ballpark estimate. That's okay. Now, how are you going to find out where the zeros really are? What we're going to do about this? Time wash it forward. Get we're going to have room. I'm gonna borrow them. Okay. Quadratic formula. Now I'll write that up here. Because I know you're not able to see that way in the back. If you don't already know it, at least one person, as I said, got off into quadratic formula. Okay. There it is. Now, look at the video. So, well, what do you get? What's A, B, C? What are A, B, and C? What do you get when you plug in that? Right on it. Get some colors when you're doing. Oh, for crying out loud. Well, I'm gonna say it again. So if you want to hear it again, stick around, but otherwise, get on with your life. Okay. Okay, well. I think I did all this on screen, but just basically to go back. Here's your function. We calculate the axis of symmetry. It's at x equals -3. Axis of symmetry is a vertical line. It x equals -3. We drew that line, nothing else on the graph. Okay, then we plugged in x equals -3 into the function. We calculated then s of -3, and that came out -22. Right here is the calculation. Okay, we just do s of -3 meaning we plug -3 in for x, get these numbers, and they come out like this. That gives us y coordinate, the vertex, because the vertex lies in the axis of symmetry. When x is -3, y is equal to -22. So we do y equals -22, line put it there. And then we calculated y-intercept. We just plug in 0 for x, because that's what happens when we go on the x-axis. On the y-axis, s of 0 is -4, so the y-intercept was at 0, -4. Things get cramped over here. Once I had the y-intercept, I could draw this part of the curve. Then I drew this part of the curve, but I kind of choked it. But there's board, so the curve's not all that symmetric. Over here, I did a quick curve, maybe a little more symmetric. It's probably not that great. Okay, we want to find the zeros. We want to find where the graph crosses the x-axis. That happens when y equals 0. If y equals 0, then you have this function equal to 0. I never did write that out because we were pressed for time. But here's where your zeros are at these x values. We just plug enough A, B, and C in, and we do the arithmetic, and we get -3 plus or minus 3.3, which gives us -3 plus 3.3 gives us 0.3. -3 minus 3.3 gives us -6.3. Okay. Now, I'm a clumsy picture here, but here's a 0.30. And then over here, 6. The zeros or the x-intercepts of the function. And that's a pretty good synopsis in this series of examples, which you need to know about quadratic functions.